So in this problem, we need to show that the line x plus y equals to 5 touches the circle x squared plus y squared minus 2x minus 4y plus 3 equals to 0. And we also need to find out the point of contact. So let us begin. First, what we'll do, we'll start with the equation of the circle, and from this equation, we will try to find out its center, the coordinate of the center as well as radius. So here we have x squared plus y squared minus 2x minus 4y plus 3 equals to 0. Now what we'll do, we will compare this with the general equation of the circle. The compare with the general equation, which is x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. So this is going to give us 2g equals to negative 2. 2f is going to be equals to negative 4, and the value of c comes out to be 3. Now g comes out to be negative 1, f will be equals to negative 2, and c stays as 3. Now we can immediately define the coordinates of the center. The center is defined by negative g comma negative f, which means that for our case, since g is negative 1, so negative g will become positive 1. Similarly, negative f will become positive 2. We have the coordinates of the center. Let's find out the radius. Now the radius is defined by r equals to the square root of g squared plus f squared minus c. So g squared will be 1, f squared will be 4, and c value is 3. So we have 4 plus 1, that's 5. 5 minus 3 will be 2. So we have square root of 2. That's going to be the radius of the circle. So we have the circle which is centered at 1, 2. We have to show that a line with equation is given by x plus y minus 5 equals to 0 is tangent to the circle. So we'll suppose that it is tangent at point A. Now how do we show that? To show that it is tangent to the circle at point A, we're going to use a formula here. So let's say we have a point with the coordinates x1, y1, and we have another straight line with the equation ax plus by plus c equals to 0. Then if we drop a perpendicular from that point on the straight line, then this perpendicular distance is given by the formula. We'll take the absolute value. In the numerator, we're going to have ax1 plus by1 plus c. All we have done was taken the coefficient of x of the straight line and multiply it with the x coordinate of the point. And then we add it to b. b is the coefficient of y, to the y coordinate of that particular point, and add the constant term. And in the denominator, we take a squared plus b squared. Now in a case also, C, if we join point C and point A, definitely CA is going to be perpendicular to this line. So we'll assume that this is perpendicular for the timing, let's say. Then the distance CA, which is the perpendicular distance, will be given by, we'll take the absolute value. Now we have 1, which is coefficient of x, multiplied to the x coordinate of C. So that's 1. Then we'll take the coefficient of y, which is 1. This will be multiplied to the y coordinate of C. So that's positive 2. And then we add the constant term, so that's negative 5, divided by the square root of, we'll take coefficient of x, that's 1, square it, and add it to coefficient of y as square it as well. Now CA is nothing but the radius of the circle, and we have already found its value, that's square root of 2. This will be equals to negative 2 divided by square root of 2. So square root of 2 equals to negative square root of 2, and absolute value of square root of 2 is nothing but square root of 2. This tells us that this radius is exactly equals to the perpendicular distance CA, which means that the line must be touching the circle at that point A. So we have verified the first part. Now our goal will be to find out the coordinates of point A, that it will be the point of contact. So let us suppose that the coordinate of the point of contact be x1, y1. Now this point A is going to lie on the circle as well as on the straight line. Since it lies on the straight line, we can say the point x1, y1 is going to satisfy the equation of the line. So we can replace the value of x with x1 and the value of y with y1. So we get x1 minus y1 minus 5 equals to 0. So if we isolate y from here, the y1 will be equals to 5 minus x1. We'll keep this aside. Now this particular point x1, y1 is also going to satisfy the equation of the circle. So that means In the equation of the circle, we can replace x value with x1 and y value with y1. So let's do that. So we are going to get x1 squared plus y1 squared. Then we have negative 2x. So we'll get negative 2x1 minus 4y1 plus 3 equals to 0. So what we'll do, we'll substitute the value of y1 in the equation of the circle with 5 minus x1. So we get x1 squared plus 5 minus x1 whole square minus 2 times x1 minus 4 times 5 minus x1 plus 3 equals to 0. So let's simplify. We get x1 squared plus 25 minus 10 times x1 plus x1 squared minus 2 times x1 minus 20 plus 4 times x1 plus 3 equals to 0. So here x1 squared and x1 squared, that's going to give us 2 times x1 squared. Then we have negative 10x1, negative 2x1, that's negative 12. And then we have positive 4. So negative 12 added to positive 4 will be negative 8x1. Then we have the constant terms. So with 25 minus 20, that's going to be plus 5. And 5 plus 3, that's going to be 8. This will be equals to 0. Now, what we can do, we can factor out 2 from each of the terms to get x1 squared minus 4x1 plus 4 equals to 0. And this is nothing but x1 minus 2 whole squared equals to 0. Solving this, we get x1 equals to 2. Now that we have the value of x1, we can also find out the value of y1. So y1 will be 5 minus x1. So y1 is 5 minus x1, which means we have 5 minus 2 equals to 3. So we have found out the point of contact, so that's going to be 2, 3.